Alright, I am never totally sure when this starts recording, but I think that it is. I would like to go through one of our homework assignments on solving radical equations. It may help some people. So I have the answer key posted on our school website that you can access. I believe that when you log into your Edline that there's a link to all of your current classes, or at least I hope. Alright, so we have a radical equation, and when you have a radical equation, you want to have first isolate the radical by itself, or at least isolate the term that contains the radical. In this case, the radical is already by itself. It equals 4. We need to get rid of this radical, so we square each side. Because think for a minute what it means, to take the square root of a number. If you have the square root, say, of 25, there's an index of 2 that's implied there, and you can rewrite 25 as 5 squared, and then I can just come in and say this exponent 2 divided by this index of 2 is just 1, and I have this. If I have the cube root of 27, then again, see, when the indexes are larger than 2, we write it out. When it's 2, it's just implied. Just like if you have a coefficient of 1, it's implied. We typically just write x. Or if you have an exponent of 1, we just write x. Sometimes visually it's helpful to put those exponents or coefficients or that index in there. Like I say, sometimes it helps me out, at least sometimes, to just see it. So 3 to the third power is 27, and 3 divided by 3 is 1, so I can pull out that base of 3. So when I have a variable expression, and there are properties of square roots that if you have the square root of a product, it's the same thing as breaking up the square root. So if sometimes you look at these equations kind of in a reverse way. If you have the square root of a times the square root of b, you can look at it as the square root of ab. So if I have the square root of, say, x minus 1, and I square that, then what I have is the square root of x minus 1 times the square root of x minus 1. I have the square root underneath 1 radical, and you can see that when you square it, you're getting an exponent of 2, and then 2 divided by 2, that radical goes away. So when you have a radical and you square it, you don't have to illustrate all of these steps, but behind the scene, that's what's going on, right? So when I square both sides of this, I don't have to illustrate all of that. My experience tells me, hey, that radical will go away, and I have 3x plus 2. And on the right hand side, I have 16. Now, when we square both sides of an equation like this, we introduce the possibility of extraneous solutions, because we're no longer solving this equation. We have a new equation to solve. They should have the same solution set. However, when we squared both sides of the equation, we introduced a possibility that this second equation has additional solutions that the original one didn't. So that's why we have to check our answers, and when they don't check in the original, we just call it, hey, this produced extra solutions, extraneous solutions, and we ignore them. So this technique, when you square both sides, you're going to have to check your answers each time. Alright, if I subtract 2, and if I divide. Alright, so let's check and see if we agree that that's our final answer. Right now it's just our possible solution. So if I check it, and most of the time you can do these checks just on a calculator, plugging it in real quick, but I've got 3 times this fraction plus 2. And the big question is, when we reduce this, will it be, when we evaluate it, will it be 4? So when I do this multiplication, the 3's cancel and I have 14 plus 2. Hey, that's the square root of 16. The square root of 16 is 4. So yes, I believe that this 14 over 3 is my solution to this equation. All right. Let's take a look at the next one. Now, how is it different than the first one? Well, it has one radical and the other one had one radical, but on the left-hand side we have 2 terms. Terms are separated by addition or subtraction. This first term has my radical. This second term, that 6, I need to isolate the term with the radical. See, last time it was radical equals. Well, I need radical equals. So I need to add 6 to both sides of this equation, or I just typically think of it as this term changes side, and when it changes the side of the equation, it changes sign. So I get 8. Now I have the same problem that I did previously with different values, the same idea. I'm going to come in and square the left-hand side, and to balance the equation, the idea is to square the right-hand side. When I do that, I introduce the possibility of an extraneous solution. So that's why I need to check my answer when I get it. And I get that 5 plus 59 is 64, so 5 minus a negative 59 is 64. So now I'm not afraid of negative answers, but I am concerned about taking the square root of a negative number, because we're working within the set of real numbers, and we can't take the square root of a negative number within the set of real numbers. So let's plug it in and check. We've got 5 minus a negative 59 minus 6, and the big question is, does that evaluate to 2? All right, here with the double negative there, I just add those together. So hey, I get 64. Oops. And question is, will this be 2? Square root of 64 is 8. 8 minus 6, hey, that is 2. This does check. So I'm pretty confident that that negative 59 is my solution. Hopefully that's what I had, yeah, here on the key. All right, let's take a look at our third problem. All right, so I have 2 terms. The first term contains my radical. Then I have this constant of 5. I need to get this term with the radical by itself. I need to move 5 to the other side of the equation. I do that by subtracting 5 from each side. So I've got the opposite of 4 is equal to the square root of the quantity x minus 2. And if I subtract that, I have this. All right. Well, I have a negative on both sides. If I multiply both sides of this equation by a negative 1, why these change to positive values. Now, I typically don't bother to get, the directions will often say, or the process will say isolate the radical, and some students will divide both sides by 4 to get that radical by itself. What I typically do, if there's a multiplier there, I just leave it there, because sometimes I'll get fractions on the other side of the equation if I divide by that constant. When I square both sides of the equation, you have to realize what this exponent of 2 means. That I've got 4 times this radical, and then I'm multiplying it by 4 times this radical. Now, the order of multiplication is not important. You can shuffle these factors around. So I can multiply the 4 times the 4 then multiply my square roots together. So the 4 times 4 is 16, and when I take this product, we've seen that when you square, the radical goes away. Now, don't forget to put parentheses around that, because it'll be 16 times whatever that number is, the entire number. So you'll have to use the distributive property. And typically, we don't show those steps, but for the beginning student, maybe on the first few problems, until you get the hang of it, maybe some people want to illustrate that. Now, thanks to Mr. Eppert, I have a little online calculator here. And because I don't know what 26 squared is. Hey, 676. Now, I could distribute. Let's see if that 676 is divisible by 16. All right, so I'll just leave it. I'll just distribute it. So, two-step equation, we'll take the 676 and add 32. That'll be my numerator. Then divide this by 16. And I get 44 and 1/4. And if I will change it to an improper fraction, if I go math and hit that fraction, yeah, sure will. 177 over 4. That's kind of small for me to see. And I typically, back in the days when you were learning arithmetic and learning about fractions, they always had you convert improper fractions to mixed numbers or to decimal numbers. And I don't know what, later on in mathematics, it seems common that they just kind of abandon that idea without any explanation, that oftentimes you will see answers in the back of textbooks or teachers or professors just leaving things as improper fractions. I could have left it as 44 and 1/4 or 44.25. I do want to be careful and not give decimal approximations, to be exact. If I want to give the answer of 1/3 as opposed to, 0.3, because these 3 go on forever. That's just the decimal approximation. This calculator has approximated that fraction to this many decimal places, to like 9 decimal places. All right, but anyway, let's plug this in and check and see if this is in fact a solution. So on the left-hand side, I have -4. I've got this 177 over 4 minus 2 plus 5. And the big question is hey, will this evaluate to a -21? So let's just use the calculator. I could sit there and try and do it by hand, but I don't think that would be very fun to just watch me struggle with my arithmetic. All right, 177 divided by 4 minus 2. Okay, that's that first term. Now I'm going to have to tell it that I don't want the plus 5 to be underneath that radical sign, so I hit that arrow, plus 5, and hey, we got -21. So this guy does check, and this is our solution. I'm wondering now if my key says 177 over 4, or if it has a mixed number or decimal number. I would think that that's probably what it says. Yeah, 177 over 4. So you kind of know that you're beginning to understand the problems when they seem repetitive in nature. When you're doing the same idea over and over, then you know you're kind of getting it. So we have 2 terms on the left-hand side, and we need to get the term that contains the radical by itself. Now, we do have to be careful with signs and stuff. That negative sign, I'm going to keep that associated with that term. So some people often will change this to addition of the opposite to help emphasize that. You don't have to do that. It may help some people. So on the left-hand side, I have this negative sign, And when I subtract 8, I get 2. Now, so let's suppose that I multiply both sides of this by a negative 1. So, hey, I have this square root plus 5 is equal to negative 2. Now, remember, I had a discussion about square roots that technically this is the principal square root. And the principal square root should always return a non-negative number, 0 or positive. Here, the claim is that you're going to take the x is going to be some value. Maybe it's 0, maybe it's 4 to get 9. But when you take this principal square root, you'll never get a negative number. I don't have to go any further. I know that this equation has no solution, because you'll never be able to give me a real number that when actually, let me take that back, that you give me a non-negative number, because I can only take the square root of 0 or positive numbers, and I get 0 or positive because of they define this to be a function. It is true that, say, that the square roots of 4 are 2 and negative 2, but the principal square root of 4 is just positive 2. Alright, so this guy has no solution. And there we have it, no real solution. And that's I probably am better in saying, real solution. When we do get to complex numbers, we're not going to be looking at these radical equations and looking at them with studying the complex numbers. We're just going to look at quadratic equations. All right. On the right-hand side, I have two terms. Neither of those terms have a radical. On the left-hand side, I have a radical, so it is isolated. To get rid of that radical, I square both sides of the equation. It's awfully easy to forget that exponents don't distribute. If you have a coefficient, then that coefficient follows the distributive property. Everything inside the parentheses gets multiplied by 2. But when you have an exponent, this is not x squared minus 2 squared. Remember that when you have x minus 2 times x minus 2, that you take this x and you distribute it to the x minus 2, and you take that negative 2 and you distribute it through there. And if I distribute that to those two terms, and then if I distribute the negative 2 to those two terms, I get these middle terms that are like terms, and that you can add them together. So, and a lot of people do that in the form of a table, but I mean that's truly what the distributive property, what the math says, and then various teachers along the way have presented this in a way that students maybe can see the pattern easier than writing it like I just did. Whatever pattern that you see that works for you, that's consistent, is fine to use. Alright, so on the left hand side I have x, and over here I have x squared minus 4x plus 4. Alright, so I have a quadratic equation, and I have various ways that I can solve quadratic equations. The ways that will always work is completing the square or the quadratic formula. Sometimes you'll be able to factor it, and when we can factor it, it's usually just a quicker solution, especially if that leading coefficient is a 1. If that's a large number and it has a lot of factors, then my trial and error can sometimes take me longer to find the correct factors I'm looking for than just plugging in the quadratic formula. But oftentimes we're restricted by what the directions say. So here, if I just have x minus 1 and x minus 4, I get two possible solutions, because when we square both sides of the equation, we introduce the possibility of extraneous solutions, because we're finding the solution to this equation, and we know that it will have the same solution as the original equation, but possibly, if more answers, possibly extra answers, extraneous to the first equation. So we need to check that. Let's move this out of the way and check these two values. So if we plug in 1 on the left-hand side, we have the square root of 1. And the question is, when we evaluate, well, and again, the principal square root of 1, and we have 1 minus 2. Well, those are not equal to each other. The principal square root of 1 is not equal to negative 1. I have to throw that solution out. All right, so let's take a look at 4. If I take that principal square root and 4 minus 2, I get, and the question is, are those really equal? And I get 2 is equal to 2, so this guy checks. All right. Yeah, that's why I said note that x is not equal to 1, meaning that it's not in the solution set. I probably shouldn't have stated it like that. I don't want to confuse people. Well, let's move this to a new slide. Alright, so on the left-hand side I have two terms. One of these terms contains a radical. I need to get that term by itself, so this other term, I need to move it to the other side of the equation. Alright. And you can write 8 plus x or x plus 8 because addition is commutative. The order in which you add does not matter. So now if we square both sides of the equation, we'll get rid of that radical. So on the left-hand side, if we square it, don't forget to square the 6. And on the right-hand side here, we have x squared plus 16x plus 64. Hey, you know, a perfect square. We've seen in completing the square, if you're going the reverse way, since half of 16 is 8, and 8 squared is 64, that if you were going the reverse way, if somebody gave me that trinomial, I'd be able to factor it to a perfect square pretty easily there. All right, so a quadratic equation, I'm going to get it in standard form and see if I can factor it. If I subtract 36x from each side, I'll get a middle term there of negative 20, I think. And here. So the leading coefficient is 1. And 64, you know, 2 to the 6th power, you've got a lot of factors of 2 to search through and find the right combination. But I believe, and since that's positive and the middle term is negative, I know it's going to be a negative and a negative. And I think that there's 2 factors of 2, and here's 4 factors of 2, and that 4 times 16 is 64. Yeah. So I've got 4 and 16 as possible solutions. Now they could be extraneous. I know there's solutions to this equation. However, I have to double check and see if there's solutions to my original equation. So if we plug in 4, on the left-hand side we've got 6 times the square root of 4 minus 4, and the big question is, will that evaluate to 8? We've got the square root of 4 is 2, 6 times 2 is 12, 12 minus 4 is 8, so hey, that guy checks. Alright, let's see about this other one. We've got 6. And question is, will that evaluate to 8? So the square root of 16 is 4, we've got 24, and 24 minus 16 is positive 8, so that one checks as well. Alright. So I don't know why I'm erasing that, because we're moving on to the next problem. Take a look at this guy. Alright, so we have 2 radicals in our equation this time, and sometimes these can be a long problem, especially if there's some additional term over here that's not 0. You know, if you have some expression over here that takes longer to solve and you have to be repetitive in the process, and we see a few of those type of equations on the next assignment. But here with just a radical equal to a radical, why it's actually one of the more easier situations, because when we square each side, we get rid of the radical. So we've got 6x plus 8, 2x minus 5. We've got 4x. If I take away 2x from each side, if I subtract 8 from each side. All right. Now, I'm not fearful of negative answers. I am fearful that when we plug it in, that we'll be taking the square root of a negative number. So when we do have things that are like a no solution or something, it's not because the answer is negative. It's because that when when you plugged it in, that you violated the domain, that your function, that this principal square root can only take the square root of non-negative numbers. So let's plug in and see if the left-hand side does evaluate to the right-hand side. If we have 6 times negative 13 over 4, and the question is, so on the left-hand side here, what do we have? Well, I'm just going to figure out the number underneath the radical, not worry about the radical for a moment. 6 negative 13 divided by 4 plus 8. So that this guy is a negative number. And I can stop right there, because we're going to try to take the square root of a negative number. The calculator is going to tell us that there's an error. So if I had put in, it's hard for me to see even up close that blue shading there. I'm expecting the calculator to tell me some type of domain error. There we go. Well, non-real answer. So I may be able to come in and change the mode on some of these calculators to some type of complex. Yeah, the A plus B, see where it says real right there? I might be able to come down on these calculators and change it to have it work in complex numbers, but we don't need to do that. Alright, so we have no real solution. No solution. Because the undefined will not equal undefined. Even I don't know if this side is taking the square root of a positive or negative number without plugging it in, but I can stop. I don't have to find out, because I know that undefined doesn't equal undefined in terms of mathematics. We compare complex numbers, or the real numbers are a subset of complex numbers. All right. Take a look at the next one. Getting closer to getting done. I don't know how long this video is running, so. But you can fast forward it. You can skip over the problems. You can slide that bar across the bottom. And if you can't, let me know, because the default is that when it puts these on Edpuzzle that you can't fast forward, but I can remove that default and allow students to be able to fast forward to the problem they want. So we have a radical equal to a radical, just like last time. We'll square each side. We've got x squared minus 4 is equal to 3x. We have a quadratic equation. If we get this quadratic equation in our standard form, sometimes they may say a general form. First, I'll look at it and try and factor. If I can't factor, I'll apply the quadratic formula. But here, I see that we can, and even, if you don't see that you can factor it and you apply the quadratic formula is going to give you an answer of 4 or negative 1. It just, as far as time goes on quizzes and tests, you want to do the problem, quickly and efficiently. All right, now, if we're just at this point saying those are possible solutions. We're not ready yet to say that both of these are solutions, because we haven't checked them. So on the left-hand side, if we have 4 squared minus 4, will that equal, the question is, will that equal my 3 times 4? So I've got 16 minus 4, hey, that's radical 12, and over here I've got radical 12. I don't have to simplify the radicals here. Hey, in a check, I know that that checks and that this guy's solution is good. Now I can immediately see that this negative 1 is not going to check on the left-hand side. We've got this negative 1 squared minus 4, and then on the right-hand side we have 3 times negative 1. So 1 minus 4, that's the square root of a negative number. And yes, when we go into complex numbers and we can we'll be able to look at the square root of negative numbers, but when we're solving these radical equations, we're working within the set of real numbers. So even though in terms of complex numbers 3i does equal 3i, within the set of real numbers we're going to say, hey, there's no real solution. You have to go to the set of complex numbers to have a solution to this equation. All right. Now with our index, it's changed now to a cube root, and we can take the cube root of negative numbers. So, when I think that when that index is odd, that we can get away with, the technique doesn't require that we check for extraneous solutions. It might be smart to check your answer just to check your own arithmetic, but the technique itself, I don't believe, requires it. All right, so we've got, see, I have to raise it to the third power because the index is 3. And be careful, when you're tired, you'll sit there and say that 3 to the third power is 9 because you'll accidentally multiply them when really it's 3 times 3 times 3. All right. So like I say, I don't have to take the time to check other than to make sure that I haven't made a silly arithmetic error, which I am very guilty of a lot of times. All right, so that's the same as I have on my key. Let's come over here. And we see another index of 3 in this one. All right, so again, since it's a cube root, I'll raise it to the third power, and to balance the equation, I do that on each side. That will get rid of that cube root. And so now I have a quadratic equation. Get it in a standard form, and try to factor it, and if we can't factor it, use the quadratic formula. So I'm getting solutions of 4 and negative 2, which are both going to be good because, you plug in 4, you've got 16 minus 8. Hey, that's the cube root of 8, which is 2. Plug in a negative 2, you've got 4 plus 4, that's 8, cube root of 8. Even if this were, well, maybe we should, I suppose, I don't think that you would ever, on the left-hand side, have a cube root of negative 8, and it would evaluate to negative 2, but then on the right-hand side, they claim that it's positive 2. So maybe I should double check and make sure that the technique, well, when you're raising it to an odd power, though, it would take care of that negative sign. I don't think that the technique requires that we check for extraneous solution when we have an odd index. I'm going to stick with that until I have proof that it's otherwise. Boy, I'm glad I can zoom in on this and make this bigger because these indexes are sometimes difficult for me to see. Now, there is one thing that's common about maybe I don't have to check for extraneous solutions, but I definitely do want to isolate that radical when I'm trying to get rid of it. So, or at least the term that contains that radical. I need to subtract 6 from each side to move the 6 to the other side. And just to make the number smaller, because I know I'm going to take it to the third power, I can see that both sides are divisible by -2. So if I divide the left-hand side by -2, then I have to divide the right-hand side, and I get my radical. And don't lose that index. And this guy's positive, and that's 4. And 4 cubed is 64, and I don't know what 8 cubed is. I'd have to come over to the calculator. So if I cube this and cube that, I get 8 minus 3 is 64, and that's 67. And like I say, there's not a requirement for me to check for extraneous solutions. If for some reason this number doesn't check, it's because I've made a mistake in my solution. There's nothing wrong with the technique of how to get this answer. I just may not have applied the properties of equality right. All right, final one. All right. On the left-hand side, now I'm back to an even root, which means I have to consider extraneous solutions. Like if this were a 4th root or a 6th root, we would have to we proceed just like we do with the square root. I've got 2 terms. I need to get this term that has my radical by itself. So we'll move this 11 to the other side, so it changes sign. When I square the left-hand side to balance the equation, I square the right-hand side. The radical goes away. Exponents don't distribute, so we have to be careful when we square that out, because otherwise you'll lose that middle term. All right, so a quadratic equation, let's try to get it equal to 0 and solve. So at this point, I don't know when I immediately look at that. You guys might be able to know for sure whether it factors. Let's go ahead and try the techniques of factoring. And if we run into problems or something, we'll just use the quadratic formula because I've got the calculator over here. I can do it either way. So the Algebra 1 team, the teachers that teach the Algebra 1 class, if you're becoming a tutor for that, they teach how to factor trinomials by this process that they refer to as the X method. They'll draw an X over the middle term. A lot of times I draw off to the side because I don't want to clutter my problem, and I don't want to have a line drawn through there and then later think that that minus sign is a plus sign. So the bottom of the X is that middle term. To figure out the top of the X, you always take the first term times the last term. And I'm not sure if they even have a process that they tell the students to circle those just as a reminder of how they get that top. You'll have, if you're tutoring, you'll just have to look at their notes or talk to them and find it. Try to imitate the exact way that their teachers are doing it, even though if you change it slightly to a beginning student, that sometimes they find that confusing. All right, so the game begins on our trial and error that we're trying to find 2 values that when multiplied together give me the top of the X, but yet when added give me this bottom value of the X. Now with the product being positive and the with the product being negative, no, the product take that back. The product being positive and the sum being negative, I know that both of these values are negative when I'm searching for my values. And I think the other day in class, in one of the classes, I had that backwards just like I almost started to say. So when I was looking for the possible factors on this problem, I was having a difficult time in my trial and error finding this. Now what I often do is I'll look at this value of 80 and I'll write its prime factorization. So 80, I believe, is 16 times 5. Let's double check it. I don't trust myself. Yeah. Clear the calculator. Okay, yeah. So now I need to find the right combination of values that add together to give me the 47. So if I have 24, yeah, see, I'm not seeing it. I paused the video for a minute because I couldn't see it, so you guys are probably screaming. Look up here at my work. Do you see how this 121, when I subtracted 1, rather than writing 120, I wrote 20. You know, I may have done something like that day in class too. This guy, 120 minus 1 is 120, not just the 20 that I had. So that's kind of embarrassing. And I wish I could come in and edit the tape and cut out this portion of it so that no one would ever know that. But so if you're watching this, don't go running around telling everybody how stupid I am about subtracting 1. All right, so if well, I don't know what time you're watching this, but it's incredibly early. It's a little bit before 5 a.m. I know that's not an excuse, but all right. So if I multiply these guys together, I've got a 480, and down here negative 47. So this guy is not of any help. So if I look at the prime factorization of 480, that'll help me a little bit. So let's do that. Alright. I have 5 factors of 2. So we do have 32 times 15 is 480. Okay. So picking taking these values and grouping them together so that we know that the product will be 480, but we want to add it up to the negative 47, well, to 47 right now. So the 32 times the 15 and 32 plus 15 gives me the 47, you know. So sometimes you'll have to shuffle these factors around, and I just remember one of the students actually, you know, again during class I just couldn't see that and stuff, and I had a mistake up here, and then somebody said, well, 32 and 15, hey, that works. And I was like, yeah, you know, so thank you to your contribution, because sometimes when you don't see it and you're in front of a group of people, even as a teacher for years, it can be frustrating that you know that as a student. All right, so I'm just going to move this out of my way. I don't think I need it anymore, but 32 and 15. Now, it used to be several years ago, you'd have different teachers would use the results of this X differently, and they got together and said, hey, let's consistently place this information in the body of a table, because there's a connection that when they taught them how to multiply binomials, they put it in a table. But this time, the information that we get from our trinomial, we put along one diagonal in the interior of the table, and the two values of the X go along the other diagonal. And if along a diagonal they could change places, that's not important, but they do need to be diagonal to each other. So we look here, and we can factor each one of these guys by, where did by, is it 16? No, 8. All right. And these guys here, a negative 15. So a negative times a negative is positive. See, when I saw these diagonals both being negative and this being positive, I knew that I was going to have negative numbers on the exterior there. If I look horizontally here, the 4 and negative 15 we say are relatively primed with each other. There's no other number other than 1 that divides both of those, but we do have a common x. And vertically here, we see that both of these values are divisible by 4, and that they both have an x, and we can check x times 4x is 4x squared, x times the negative 15, negative 15x, negative 8 times 4x, negative 32x, negative times negative positive. So, like I say, if you're tutoring, I'll double check, but I believe that that's the way, and you should be able to determine that. Hopefully the student won't be so lost that they've never written this down. Hopefully they've written something down. And we have 4x minus 15 is one binomial, and x minus 8 is the other. So that was a long and embarrassing drawn-out process. Sorry about that, especially for the last problem. I'm sure you probably fast forward through this by now. A possible solution is 15 over 4. Another possible solution is 8, but we need to check that. So I'm just going to, I've got so much to shrink up, I'm just going to move this to the other page and take along my values that I'm going to check. Alright, so let's check the 15 over 4. On the left hand side we have 11 plus radical 3 times this 15 over 4 plus 1, and the big question is, when we evaluate that, will that be 7.5? Alright, so let's plug in a calculator and check. The left hand side, alright, so on the left hand side I'm getting 14.5, and on the right hand side I should get 7.5, right? Yeah, so hey, that's not checking. So I'm getting that this is not a solution, and that was my only candidate. So I'm thinking right now, but of course, being the last problem and the previous mistakes that I've made, I'm even second guessing and questioning myself. So sometimes you have to set it aside and come back to it later and not try to do some marathon session on a homework problem. Yeah, oh, wait a minute. X equals 8. Oh! Oh, you're probably yelling at me. I had not just the 15 over 4 to check, but also the 8 to check. So, oh, goodness. Alright. Yeah, it's true that this one isn't a solution, but we haven't checked the x equals 8. I don't know what's the matter with me. Alright, let's check this. Alright, when on the left hand side here, 3 times 8 is 24, 24 plus 1 is 25. Square root of 25 is 5. So on the left-hand side here, I'm getting 16. And on the right-hand side, I'm getting 16. So this one does check, and the other one was extraneous, and this one checks. So we are done, and I probably should destroy this tape and never let it be seen, but hey, I'll talk to you later. Bye.